Hello everyone, this is Miss Berlin and this lecture video is a sample problem related to the integration and application of cosine law to the Coulomb's law. We have here the problem, the balls of a lato-lato are identical. Yung laruan, dalawang ball ng lato-lato, they are identical and are in equilibrium at a charge of 2.3 times 10 raised to negative 6 coulomb each, with each string making an angle of 4.2 degrees from the y-axis. The string is then 0.2 meters long. Find the electric force between the spheres or between the balls of the lato-lato. We have here the Q1 and the Q2, and the charge of this is identical since they have the same material and same size. The charge of these two objects is, or the charge, is 2.3 times 10 raised to negative 6 coulomb. And then the length of the string, both of this has an equal length, is 0.2 meters. Dagdagan natin yung size, 0.2 meters, both of that. And then, the length is 0.2 meters, but then the theta of the length, or the angle of the length from the vertical axis, this is the vertical axis, the center, and the angle of that, each of the string towards here, towards that angle is 4.2 degrees. 4.2 degrees. On the other side, it's 4.2 degrees as well. So, we will be trying to find the electrical force. But then, if you will try to find the electrical force, we only have the Q1 and the value of the K. We don't have the distance. So, in order for us to solve the problem, right, from the problem, we have the given values, the charges of the lato-lato balls, which is 2.3 times 10 raised to negative 6 coulomb. And then the length of each string is 0.2 meters. Then the angle of each length, or the angle of each string from the vertical axis or from the y-axis is 4.2 degrees each. So adding that will become 8.4 degrees in total, the theta. And we will try to find the electric force, but we only have, again, the charges and then the distance. We don't have the angle and the coulomb, but we don't have the distance, right? So for us to find the distance, we will be using the cosine law. And for the step 2, we will be now, since from the cosine law, we can obtain the distance of each balls with each other. And by step 2, we will be incorporating or substituting that value here. So we can now use the electrical force or the Coulomb's law equation. But then, let us first use the cosine law. So basically, the cosine law is this one. C squared equals A squared plus B squared minus 2AB cosine theta. Right? The cosine law is being used to find the length of a side on a triangle. On the case of the lato-lato ball, here, we don't have the x, right? We don't have the x here. And that is what we want for the distance. We don't have the x. So we will be trying to find the x here. Back here in the equation, again, we are using this cosine law here. If we want to find the length of the side in a triangle when the length of the other sides and the included angle are known. So, we know the angle, which is 8.4 degrees in total, and each side of the triangle from the image here in the lato-lato, which is 0.2 meters each of side of the triangle. Basically, this forms a triangle, right? We have the angle here at 8.4 degrees total, 4.2 plus 4.2, that is 8.4. And then the side of triangle is 0.2, the other side is 0.2 meters. So basically, we want to find the other side of the triangle, which specifically states that this is the distance of the sphere from the other sphere, right? That is why we are using the cosine law. Let us go back here in the cosine law. In the context of this problem, the cosine law is applied to find the distance, which is x. So instead of using the c squared, we will be using the x squared to denote the horizontal line and applying the same variables in the equation. So again, we will be using the x to connote to find the distance between the two balls in the lato-lato toy. Basically, we will have now the x squared equals a squared plus b squared minus 2ab cosine theta, wherein the x here is the length of the side opposite the angle theta. This is the length of the, here, you have the theta here. This is the length, the x, and this is the opposite It is the opposite of the angle here, the theta, right? This is why we are using the cosine law. Now, the angle theta is the degrees that has been given from the problem. A and B are the lengths of the other two sides, which are both 0.2 meters. A is 0.2, B is 0.2 meters as well, right? So, substituting, we now have here x squared equals 0.2 meters squared, the A, and the other length is 0.2 meters squared as well, minus 2, substitute lang, 0.2 meters for A, 0.2 meters for B, and then the cosine, and then the angle of the theta, which is 4.2 each string from the vertical axis. Adding that 4.2 plus 4.2, that will become 8.4 degrees. And the next step is, of course, you will square that based on the equation. 0.2 meters raised to 2, that will be 0.04 meters squared. Same here, 0.2 meters squared, and then that will be 0.04 meters squared as well. Then 2 copy, then 0.2 meters times 0.2 meters, that will become 0.04 meters squared. And then cosine 8.4 degrees. The next thing that we did is we add this one. We add 0.04 meters squared and 0.04 meters squared. Then you now have 0.08 meters squared minus, we multiplied 2 times 0.04 meters squared. You will now have 0.08 meters squared. And then cosine 8.4. The next thing that I did is I find the value of the cosine 8.4 degrees, which is 0.989, right? The next thing that I did is 0.08 meters squared multiplied to 0.989, that is 0.079 meters squared. And then, of course, I subtracted 0.08 meters squared to 0.079 meters squared, and that will give us 0.01 meters squared. We only want to find the x, not the x squared. We only want to find the one-dimensional motion, right? Or the one-dimensional scalar quantity. We are not trying to find the area. Right? So, for us to do that, we will be squaring both sides of the equation so that we can eliminate the 2 here. Because if you square root this one, it will become 2 divided by 2, and that will become 1. So, that will become an x. Right? So, squaring that, you will be able to cancel the radical sign and then the 2 here. And then you will now have to find the square root of 0.01 meters squared. And the square root is 0.0316 meters. The square root of meters squared is meters. And that is equivalent to moving. Syempre, dapat mukhang matalino yung answer natin. And that is the proper way of expressing the value in physics. So, you have to move the decimal point to the first non-zero digit. So, that will become 1, 2. So, you move 2 decimal. And when moving, that is a negative sign, right? 3.16, that will become 3.16 times 10 raised to negative 2. Since we move from, is that left to right? Yes, meters. This is the answer. 3.16 times 10 raised to negative 2 meters. Basically, this is our R, or the distance which we'll be using for the electrical force. Now, we can now find the electrical force since we already have the distance, alright? So, balik tayo sa problem here. We have this one. So, we can now use this equation. The f of E equals kq1 q2 over r squared. We have the given values. We have the charges of the two balls, which is 2.3 times 10 raised to negative 6 Coulomb each. And then the distance from the calculated cosine law, that is 3.16 times 10 raised to negative 2 meters. And then, of course, the value of the K, which is 8.99 times 10 raised to 9 Newton meter squared per Coulomb squared. We only just need to substitute the given values. For the charge, Q1, that is 2.3 times 10 raised to negative 6 Coulomb. And the Q2 is the same because they are identical. And then the distance is 3.16 times 10 raised to negative 2 meters raised to 2 as stated in the equation. And then the next thing that we did is 8.99 times 10 raised to 9 Newton meter squared per Coulomb squared. We multiply the 2.3 to the 2.3, and that will give us 5.29 times 10. And then the rule of the exponent, negative 6, we just have to add negative 6 plus negative 6. That will give us negative 6 minus 6. So they have the like sign, so you just have to add, and then you will give it, you will give this one a negative sign, right? Since both of them are negative. So negative 6 plus negative 6, that is negative 12. C plus C, that is C squared. And then 3.16 raised to 2. This just is 1, 3.16 raised to 2. That will be 9.9856 times 10. And then negative 2 times negative 2 rule for exponent. When you are raising the exponent in a multiplication process, you just have to multiply that to the exponent. So negative 2 times 2, that is negative 4. Then m raised to 2 is m squared. The next thing that we will do is 8.99 multiplied to 5.29. You will have 47.55711. So usually I just copy like 2 decimal places, but then this one has a very large value, so I copied this all, meaning to say they are more than 5, so I copied it just for more accuracy. So you will have here 47.5571. And the next thing that I did is, of course, the exponents. You have to add because you have the multiplication operation. 9 plus negative 12. You will have 9 minus 12, and that will give you negative 3. You have to subtract because they have different signs. And of course, copy the sign of the value that is a higher value. So you will have here 47.5571 times 10 raised to negative 3 Newton, and then 9.9856 times 10 raised to negative 4. The next thing that we did is we divide. We divided the coefficient. So 47.5571 divided by 9.9856, that is 4.76. And then negative 3, when you are conducting the division, the exponent should be subtracted. Negative 3 minus 4, you will have negative 3. Since they are like signs, parehas silang negative, that will become positive, and plus 4. Unlike signs, so you have to subtract. And that will become 1. So basically, we won't write 4.76 times 10 raised to Newton, times 10 Newton, because it is understood that it has only one decimal point, right? So that will become 4.76 Newton lang. And this is our electrical force, the final answer to the question on our lato-lato problem. The electrical force, therefore, between the balls of a lato-lato is 4.76 Newton, having an equilibrium at a charge of 2.3 times 10 raised to negative 6. Alright, so that is all for the sample problem.